All right, so hopefully you were able to get through some of those problems. We'll post an answer key also so you can check how you did. And make sure that you get that turned in today because that will count as points for your homework assignment. So let's go ahead now and move on to sort of an extension on these formulas, which is compound interest. Okay. If we have an initial principal, which is going to be P, and when we're talking about loans, credit cards, any sort of balance, your principal is whatever you deposit into that account to begin with. So if I have $2,000 and I put that into a savings account and then hope to gain interest on that, my principal is my initial amount that I deposited. That would be $2,000 in the instance that I was just talking about. So the interest rate is going to be R, just the same as before. What's going to be different, okay, is we're going to compound this interest. And here's what compounding means, okay? It's probably going to be helpful if we compare this to simple interest, okay? Simple interest, and you may want to have this in your notes as a compare and contrast. Simple interest, your interest is only ever applied to the principal. Okay, so let's say that I deposit $2,000 at 5% interest. Year one, I'm going to get 5% of $2,000, which would be, I should be able to do this in my head, but I'm in a hurry. I think I want to say $100, but let's double check that. 2,000 times 0.05. Right, it's $100. So we get 2,000, my initial, plus $100. Now, year two, I have now 2,100. But I don't get interest on this $2,100. I still only get it on my $2,000. So I'm going to get another $100 and so on. Compound interest is different because what this means is every time I take the interest, I'm taking interest of my new balance. So if we use the $2,000 example, I'd have $2,000 at 5%, I'd end up with $2,100 at the end of that year. The next time it calculates 5%, instead of doing 5% of 2,000, it's going to do 5% of 2,100. And then I'm going to get a new balance. And the next time I do the 5%, it's going to be of that new balance. That's the difference between compound interest and simple interest. For a savings account, compound interest is great, because you're getting interest on your interest also. But for like a credit card, compound interest is not good because you're getting charged more the longer you let that money sit in there on your credit card balance. So if we look at the pieces here of what this is, P is your principal, which means, again, your initial balance, whatever you're charging or putting in. R is your rate, and that's going to be a percentage again. Now, N is the number of times compounded. And notice that we also have N in two spots. That's going to be the same value no matter what. So we could have something that was compounded yearly, which would be the example I just told you. 2,000, then you get to 2,100, then you get 5% of that 2,100, and then a year later, you get 5% of that new balance. If I were to compound it, let's say monthly instead, that would mean that I would get to use my new balance every single month. So I would get interest added 12 times during the year instead of just once, which means you would get a lot more money from that savings account if it was compounded monthly. I think most savings accounts are compounded monthly. You usually get a statement at the end of the month for how much money you've earned. What's really scary is that your credit card interest, how much you have to pay on the balances that you've purchased with your credit card, is compounded daily. How many days are in a year? 365. That means 365 times during the year they're adding interest onto your balance. It's only going to be a little bit at a time, but that's going to add up quickly, and that's why credit cards can be so dangerous. So really you just need to be able to plug into this formula here. And the nice thing about it is this formula is given to you on the EOC reference sheet, which I'm going to give you when we finish up with this packet. So you don't have to have this memorized on the test. It says you invested $150 in an account that pays 4% annual interest compounded monthly. What was the balance of your account after 10 years? Now we should probably add one more thing. This is the number of times compounded per year. Okay? So if it's compounded yearly, it would only be 1. If it's compounded monthly, that means it would be 12 because it's happening 12 times during the year. So let's work through this. $150, that's how much we started with. That's our principal. 4%, that's our rate. Compounded monthly, that means 12 times. That's our N. Okay? And then T, again, is time in years. So first we're going to write the account. Or we want to write the equation. And then we're going to plug in 10 for T to figure out how much we actually get. So I know that A, my account balance, is going to be P, which is 150, times 1 plus my rate. Remember, we have to write it as a decimal. So it's going to be 0.04 divided by 12. Because it is an annual interest rate. So if it's going to be compounded monthly, I can't do 4% every single month because that would make it more. That would be like a 48%. By the time you add all those up during the year, your annual interest would be more. So we're taking that annual amount and dividing it down into 12 months. Now, kind of logically, you think, but hey, if I'm getting smaller interest, that's not going to give me as much money. But the fact that it's compounding, it actually does end up giving you way more money. So I have that, and then I need to the N times T power. So again, N is 12. And what we're using for T in this case is 10. So that's what we're going to get. Now, let's go ahead and crunch all of these numbers out. Okay. The order that we need to do this in with the order of operations is really important. So I'm going to have A is equal to 150 times. We need to divide first. So go ahead with your calculators. Let's do 0.04. divided by 12, and I get 0.00333333. So I'm just going to put 0.0033. Let's have 2 digits. That's probably helpful. And oops, I need to add 1 to that, so that would be 1.0033. To the 12 times 10, which is 120th power. Now, again, order of operations says that we need to do exponents first. You cannot multiply these and then do the 120th power. You're going to get a gigantic number, and that doesn't follow the order of operations. So I'm going to type in 1.0033 to the 120th, and I get 1.4849000. So let's say 1.48. So this gives me 150 times 1.48, which now I can multiply this, and I get 222.74. So at the end of 10 years, that $150 has turned into $222, which is a growth of $72, which doesn't seem like that much. But imagine if I had put in $1,500 or $15,000. That would be a fair chunk of change over 10 years of time. So, you know, it kind of pays off to save your money. All right. Go ahead and try part B. If the teacher will go ahead and pause this while they work out part B on their own, and then we'll come back together. All right, so you should have worked this out. The way that we would set this one up, let me change back to a darker color. Okay, again, we have A is equal to our principal, which is 3,050, times 1 plus, here's my percentage rate, 0.065. It's compounded quarterly. Think of how many quarters are in a football game. There's 4, so that means I compound 4 times. And again, the compound was 4. This one always goes in 2 spots, times 3, because I want to know after 3 years. 0.065 divided by 4 is 0.01625. So let's say 0.016. That means when I add, I get 1.016 to the 12th power, and I still have to multiply that by 3,050. Make sure that you do your order of operations correctly. Multiply first, which gives me 3,050 times 1.21, which gives me $3,689.98. So you see how a higher interest rate and shorter time, I ended up gaining like $600 here in just 3 years. That's also partly because we started with a larger principal amount. Okay, I just want to show you one last formula, and that's going to be how we do continuously compounded interest. Now, the rate, the formula, all works exactly the same. P is your principal, R is the rate, and T is the time. Now, this is different. Compounded continuously means basically as many times as you can possibly fit into 1 year. And the number E, everyone's like, wait a minute, E is a letter. Well, E is a number, kind of like pi is a number. Okay? E stands for this number right here. Now, just like with pi, there's an E button on your calculator, and it's much better to use the E button to evaluate this. And remember, if I split this apart, this would be P times E to the RT power. You have to do this first, and then you can multiply by P. So if you have to estimate, use approximately 2.72 for E, but it's better to use the E button on your calculator, which is usually above the LN button, which stands for natural log, because this is the natural base, and so that's where you can find it. All the setting up of the formulas is exactly the same. So now we're going to go ahead and pass out homework, and I will be back tomorrow to go over questions on this, but I really do expect that you can get most of this done on your own. It's just plugging in and working out. So go ahead and get started on that. I will see you folks back here tomorrow.